Hey guys, it's Mrs. Kerr. So I'm going to be doing the lesson with you today on adding and subtracting rational expressions. So before we even get to doing it with the variables in it, let's just remember what we do with normal everyday fractions. So for example, if we had 1/9 and 4/9, these guys already have a common denominator 9. So remember the answer is going to have that common denominator of 9. And then I just can add the numerators here. So 1 plus 4 is 5. So this guy is 5/9. If they don't have a common denominator, so 1/2 plus 2/3, remember you cannot add or subtract fractions if they don't have a common denominator. So 2 and 3. My common denominator would be 6. And just as a reminder, your strategy is you find the smallest number that they're both factors of. So 2 and 3, both are factors of 6. So I want to make both of these denominators become 6. So since this guy's a 2 right now, to make him into a 6, I got to multiply him by 3. So if I multiply the bottom by 3, I also have to multiply the top by 3. Okay, and the reason you're doing that is because 3/3 is really just a 1. So you're really not changing the value of the fraction. And then when I do that, I get 3/6. And then same thing here. This guy's a 3. I want him to be a 6. So I'm going to multiply him by 2. If I do 2 to the bottom, I also have to do 2 to the top. So this becomes 4/6. Now they have a common denominator of 6. So that 6 just goes along. And then I combine the like term. I combine the numerators. So 3 plus 4 is 7. So I have 7/6x. So just remember, this will carry over to what we're going to do today. Anytime you're doing this with the fractions, you always just keep the denominators the same once you have a common denominator and add or subtract the numerators. Okay, so now what I'm first going to do is outline the steps we're going to do with variables, and then I'll do a few examples with you so it makes sense. So with variables, it's very similar to here. You have to get a common denominator. How you get a common denominator looks a little bit different when you have the variables involved. So if possible, the first thing you're going to want to do to get a common denominator is factor the denominators. Okay. If they can't factor, we'll talk about that. But factor the denominators, and then once you have the denominators factored, you want to include every factor that is different. Okay, and again, this will make more sense once we do some examples. Then once you've gotten a common denominator, much like we did up there, you're going to leave the denominators the same. Okay, leave them factored if they're factored. And then you're just going to simply add your numerators. And since we have variables, that's going to just involve combining like terms. Okay. And then your third step is, if it's possible, if you can, you always want to just make sure you simplify your answer. Okay, that would be by factoring the numerator. You cannot always simplify, but just always double check for that in the end. Okay, so kind of keeping those in mind as our steps, we're going to go ahead and do our first example. So our first example is 2x minus 1 over 5x plus 5/6x. Okay, so our first step is to get a common denominator. So here my two denominators are 5x and 6x. Neither one of these guys will factor because they're just a single term. Okay, so I can't factor this or this. So how do I come up with my common denominator? Well, I have a 6 and a 5. So my thinking of getting a common denominator for those is the same as what you've always done. What's the smallest number both 6 and 5 are factors of or divide into? And that's 30. So my common denominator is 30, but then I can't just leave it at 30 because if you notice, both of these have a x. So I also need to include that in my common denominator. Okay, I need to include common denominator between the numbers, and then any variables, that are there also need to be included. So my common denominator is 30x. So once I know that, I got to get this guy to be 30x and this guy to be 30x. So this guy, since it's 5x right now, I'm going to have to multiply him by 6/6. This guy, since he's 6x right now, I'm going to have to multiply him by 5/5. Okay. And then we just do the multiplication. One thing you're going to need to remember, if you have addition or subtraction in a term, so like I have right here, okay, I'll kind of draw it there and I'll put a little star there. You're going to want to remember to distribute. Okay, and you're going to need to do that anytime you have addition or subtraction in a numerator and you're multiplying it by something. Okay, so let's just do the denominator first. 6 times 5x is 30x. Okay, and that, remember, that should match your common denominator. And then here, if I distribute, 6 times 2x is 12x. And 6 times negative 1 is negative 6. And then I'm going to do the same thing over here. Okay, do the denominator first. 6x times 5x is 30x. And then here it's easier, no distributing, just 5 times 5 is 25. So now you can see I've done the first step. I've gotten a common denominator. So now I'm ready to just combine these together and write my answer. So I have 30x and 30x. So I know my final answer is over 30x. It's always keep the denominator the same. And then I have to combine these numerators. Since now I'm dealing with variables and stuff, I'm just going to combine like terms. So 12x, no other x's to combine them with, so this becomes 12x. And I have negative 6 plus 25, which is 19. Okay. And then you want to be done, but just double check once you've gotten to that point that there's nothing you can do to simplify. Okay, so here, 12, and that usually is going to involve factoring, specifically your numerator. So my numerator here, there's no GCF. Okay, it's 2 terms with addition, so there's really nothing more I could do with it. So this is my final answer. Okay. All right, let's do another example. So let's do this one. 3 over y minus 3 plus y over y plus 6. Okay, so in this one, we got to start by finding the common denominator. Y minus 3, can't factor that. Y plus 6, can't factor that. So in this case, since this whole thing is kind of like one factor, y minus 3, these are connected together. Y plus 6, these are connected together. So my common denominator just has to include both of these denominators. As we said back here, your common denominator has to include every factor that is different. So it's going to have to include a y minus 3 and a y plus 6. Now, what a lot of people will say on a problem like this is, well, they already both have a y in common, and then I just have a negative 3 and a 6. So can't I just multiply this guy by 2? And the answer to that is no. Okay, and the reason is because you'd have to multiply the y and the 3, and they wouldn't be in common anymore. And just remember, if stuff is connected by addition or subtraction, it's like a single factor. This is one factor, this is one factor. I have to include them both. So now I need to get both of my denominators to look like that. So this one has y minus 3. It's missing y plus 6. So I'm going to multiply him by y plus 6 over y plus 6. Okay. And then this guy, he has y plus 6. He's missing y minus 3. So I'm going to multiply him by y minus 3 over y minus 3. Okay. And then from there, I'm going to multiply. So the good news here is, as I kind of said in the steps, leave the denominators factored. Okay, so there's no need for me to actually multiply this y plus 6 with this y minus 3. I'm simply going to leave the denominator y plus 6, y minus 3. Okay. The numerator I am going to have to multiply out because, remember, I'm going to have to combine like terms up here, and I can't do that with how it is right now. So just like I did there, I'm going to need to distribute like I did on the first example. So 3 times y is 3y. 3 times 6 is 18. So this becomes 3y plus 18. Okay. And then I'm going to do the same thing over here. Again, leave the denominator factored. So y plus 6, y minus 3. And in the numerator, that's where I do need to distribute. So I'm going to distribute y times y is y squared. And y times negative 3 is negative 3y. Okay, so once we've gotten to this point, the good thing is we have a common denominator now. So remember, your solution is always going to contain that common denominator. So I know my solution is going to be over y plus 6, y minus 3. Oops. And then I'm going to combine like terms in the numerators. And just remember, when you're combining like terms, usually we tend to write stuff like with decreasing degree. So I'm going to look at this y squared first. There's no other y squares to combine it with, so I'm just going to bring them down, y squared. And if you want, you can kind of cross them out as you've gone through them to keep track of it. And now I'm going to go to my y. So I have a 3y and a negative 3y. So those are going to cancel. So that means I don't have to write 0y. I just don't have a y term. And this 18, nothing to combine with. So I have y squared plus 18. Okay, last step is to make sure you can't factor the numerator to simplify it at all. So this is y squared plus 18, no GCF. It's two terms, it's addition. Okay, remember, can't factor sum of squares. 18 is also even not a perfect square, so there's nothing we can do. So that is my final answer for that one. Okay. Now we're going to do one more where we got to do a little bit more work. So here's our last example. 7x minus 1 over x squared minus 2x minus 3, and 6x over x squared minus x minus 2. Okay, so for this one, in order to get the common denominator, we first have to factor both our denominators. So this is one where we actually can try to factor them. So just remember, since this is a trinomial where a is 1, I just need factors of negative 3 that add to negative 2. So those would be negative 3 and 1. Okay, so I'm just going to go ahead and rewrite this here so that, looking for my other black pen. So this is going to become 7x minus 1 over x minus 3, x plus 1. Okay. And then we're going to do the same thing over here. Okay, we're going to factor. So I'm just writing down what we're doing. We're factoring the denominators. Is what we're doing first. And then same thing over here, trinomial where a is 1. So I need numbers that multiply to negative 2 and add to negative 1. So that's going to be negative 2 and 1. So my denominator now is going to become x minus 2 and x plus 1. Okay. So that's your first step, and that's the first time we've seen that. So that's kind of what I was talking about when I outlined the steps. If you can factor your denominators, you do that first. So then how the heck do we get a common denominator from here? Okay, well, my common denominator, okay, and I'll just kind of write it up here, between now these two fractions. Remember, your common denominator has to include every factor that is different. So my common denominator has to include an x minus 3. This is one factor. Remember, connected by addition or subtraction, that's one factor. It has to include x plus 1. Okay, that's my other factor. It has to include x minus 2. And then x plus 1. Okay, the reason I don't need to worry about that is I already have x plus 1 in there. So they already have x plus 1 in common, so that's in there. And then I have to also include the x minus 3 and x minus 2. So that's what I was talking about earlier when I said you have to include every factor that's different. All right, so now I got to get both my denominators so they look like this. They have to match my common denominator. So this denominator has the x minus 3. It has the x plus 1. This guy is missing the x minus 2. So I'm going to multiply him by x minus 2 for x minus 2. Okay. And then this guy here, he has x minus 2. He has x plus 1. He's missing x minus 3. So I'm going to multiply him by x minus 3 over x minus 3. All right, so remember, the good news is denominator, keep it factored. Okay, so my denominator here is just x minus 3, x minus 2, x plus 1. It doesn't matter the order, that you write it in. So, and then the numerator. So this time I'm going to have to distribute kind of FOIL, like you guys like to call it. So I'm going to have to multiply the x by both things and the negative 2 by both things. So x times x is 7x squared. X times negative 1 is negative x. And then negative 2 times 7x, that's negative 14x. And then lastly, negative 2 times negative 1 is a plus 2. Okay, so just make sure you distribute out the numerator. Okay, this one, denominator, remember, leave your denominator factored. So it's x minus 2, x plus 1, x minus 3. And then here I am going to have to distribute. Okay, so there's a couple of ways you can do it when you have a subtraction like this. Okay. What I'm going to do is I'm just going to distribute this as a positive 6x, keep that negative there, and I'll show you what to do. So 6x times x is 6x squared, and 6x times negative 3 is negative 18x. All right, so once I get to this point, now I'm ready to go to my final answer. So remember, your answer is going to have your common denominator. So x minus 3, x minus 2, x plus 1. Okay, I wrote those in different orders, but it doesn't matter. Those are the three terms in both of them. And now I'm going to combine my like terms. So what you have to be careful of is right here. This negative applies to this entire fraction. Okay, so what I'm going to suggest you do in a problem like that, where there's a negative, is turn this to a plus and then switch the signs of both of those guys. Okay, because I need to subtract 6x squared and I need to subtract negative 18, which turns into plus 18. Okay, that's my suggestion. And now combine like terms. So 7x squared minus 6x squared is equal to just x squared. And then the x's, so just be careful, I have two x's here. Negative x minus 14x, that's negative 15x. And negative 15x plus 18, so negative 15 plus 18 is 3x. Okay, and again, if you want to cross them out as you go, you can. And then I have a plus 2. Okay, and then you want to be done, but remember, you have to double check to make sure, see if you can factor your numerator. So let's see, this is, my numerator is a trinomial where a is 1. So do I have factors of 2? Factors of c that add to b? Factors of 2 that add to 3? I do. 2 and 1. So I'm going to factor that numerator into x plus 2, x plus 1. And then it's over x minus 3, x minus 2. Okay, so I'll just kind of put a star there. And I'll just say factor the numerator. Remember, you can't, but that's just if you can do it, you check that at the end. So why does that allow me to simplify it? Well, now that I have it factored, you notice that that factor will cancel. I have an x plus 1 in my numerator and an x plus 1 in my denominator. So that's going to leave me with my final answer of x plus 2 on top. Oops. And then on the bottom, I have x minus 3, x minus 2. So there's my final answer. So I know especially in that last one, there's a lot going on. So just be careful. My suggestion to you is just remember the steps, and I will talk to you guys later.